All right, we live. It's been a while. We're doing our revision session here. Oh, look, my thing not even working. Where's this? Probably should have checked this before I come on live. So we're just waiting for a couple of people to show up. Samantha, how is you doing? Revision. All right, it's working. Session. And y'all will just, tell me the topics. Why is y'all coming up with topics and thing and y'all want me to recap? I could always just pull up some past paper stuff here. Let's just warm up with a little quick algebra question from, when was this? 2019 January. 2019 Jan. Yeah, this is for Jan. Right. Hello, everybody. How things? Maybe y'all could share this in, if any of y'all from my class, y'all could share this in the class groups and tell them. So it's live. This is a free session, of course. Share the link out. Just doing some revision. You all know how to do these. What topics you're looking for? I am seeing people in my Instagram telling me some topics. I'll pull it up just now. Make the subject of the formula. How would you make this the subject of the formula? Can you do this question? Now, when you're making stuff the subject of the formula, you want you to make X the subject of the formula. Always remember, this man really calling me in an Instagram video right now, boy. Who is calling an Instagram video, boy? Wow. No longer until the Instagram video thing ring off. Anyhow, when you're making something the subject of the formula, you always need to remember all you want to see are cycle theorems and graphs and things, right? Always remember to get a little extra stuff across first now. So like this would be y minus 3p is equal to x over 5 because the 5 tied up to the x. If it looking blurry, you need to raise the setting on your side. Click the gear icon and multiply this by 5, both sides by 5, and you'll end up with 5y minus 3p equal x. Why is in the chat if you see me at top quality? So this could also become x is equal to 5y minus 15p. Y just mean yes. So yes, if you see me at top quality. So what you need to do is change the you find the gear icon somewhere down here and you just change the setting. It's supposed to be able to pull out at 1080p. All right, so this is that. That is that. So somebody just requested cycle theorems. I have that in my Instagram inbox as well. So let me pull out a couple cycle theorems questions. So let's pull out the Jan 2019 cycle theorems question. I believe there was one in that year. And they want angle PTR. Angle PTR. Here in my WhatsApp ringing off. Only time my WhatsApp is ringing off like that is when Nalini working magic in the background here. I'm suspecting that could be happening. I know that. All right, so the diagram below, not drawn to scale, shows a circle. The points P, Q, R, T, and V are on the circumference. QRS is a straight line. Angle PVR is equal to 75, and angle TRS is equal to 60. All right, determine the value of each of the angles. So tell me how you're going to find the value of angle PTR. Guys, you can call me on Instagram video. Angle of PTR. So tell me how you're working that out. Put your suggestions in the chat. Remember, the chat will come across a little delayed. We have dropped some likes on the video. Y'all know the scene. Alternate angles. I didn't even find it yet. Somebody said alternate angles. Quad angles. Well, there's a whole bunch of cycle terms you're supposed to memorize. What do you want? PTR. This angle here. All right, there's the easy one. So there's this rule that says if you have a circle, right? And you could always look up Cohen, Springer circle theorems. This is not alternate segment. Are you coming in with some real wild things here? Right, Razak say anything there. Razak say anything. Angles of Alcar say anything as well. Angle on the same chord at the circumference of the right. So Shams, all of them say it in 3 different ways, but it's all of that correct. It doesn't, expand on it a little bit, right? So, yeah, sorry about that. So, like, if I have a chord here, right? If I've got a chord there, this angle will always be the same as if you have another angle there, if you have another angle there. Angles from a common chord in the same arc are equal, right? You could use all kind of fancy words like subtended and all kind of thing, but once you say angles formed from the same chord, is a chord. This is a chord here. So angles from the same chord on the in the same segment or on the same arc in the same segment are equal. Something like that. So angles such in the circumference are the same. Nah, if you put that in Happy New Year, Leslie, and you're not going to get any marks for this, Christina. So go and check my video on circle theorems. There's a video on YouTube. You can look it up. This topic is called circle theorems. So if you have exam, when is it? Tuesday, and you don't know this is a big problem. You need to go and look up this video and memorize all them circle theorems. So what that means in this situation, this angle has to be 75. So that's the first thing I wanted you to find, PTR. Let me see if I can find the next angle that they wanted you all to find here. Next angle was TPQ. TPQ. So they want you to find angle TPQ. And each time you find these things, you need to find the value and then give reason. So just block that person or something. So TPQ. How are you getting TPQ now? Right, so if you all press like on the video, more people are getting notification. I see the numbers going up, 129 people. TPQ. So I want you to find this angle here. How are we getting that angle? How are we really getting that angle out here, buddy? All right, I kind of have an idea for that angle. Right, so every math student should have the formula booklet. If you're looking for a book with all the formulas for CSEC maths, I have a book with that. You could just, how to do this, boy. The key is just to WhatsApp this number, 472-4221 or 868. It's available in Mohammed's Bookstore in Shogunas and some other bookstores too. If you want to deliver, you could just 868-472-4221 and you're inside. WhatsApp that number. Anyhow, cyclic quadrilateral is correct. Opposite angles in a cyclic quadrilateral. You're going good. Shams, thinker, boom, bang, bang. So all of you all have good things there. This one here, this angle here will have to be 120. So you need to explain that. You see where we're going with this, right? So there's a rule that says once you draw a cyclic quadrilateral, which is a quadrilateral that has its 4 vertices touching the circumference, any quadrilateral 4-sided figure, right? 4-sided shape. The legend says that this angle plus this angle supplementary. It adds up to 180 degrees. So if you get this to be 120, then this has to be 60 because they need to add up to 180 degrees. So when you're writing this, you'll give your instructions like your explanation like angles on a straight line add up to 180 degrees or a supplementary. Therefore, QRT is equal to 120 or 180 minus 60. And then opposite angles in the cyclic quadrilateral PQRT would be equal. So the angle at R plus the angle at P must be equal to 180 degrees. So therefore, this must be 60. Why is in the chat if you understand that? All right, so we just did a topic on something that people wanted here. Let me see if there's any more to this question. This is actually a past paper, recent, green and heavy. So I don't know how good you're hearing me. If you're not seeing the video quality good, you just need to change it in the icon. Obtuse angle POR, where O is the center. So they want the obtuse angle POR. Obtuse angle POR, people. So the last one they wanted was the POR, and they didn't give O, which was unique, and O is the center. How in the world are we going to find that angle? That's actually the easiest one, but it's a little while to see. POR. So O is the center, and they want you to find the angle POR, the obtuse angle POR. Eh? So how are we finding that? If your live sticking, if anything's sticking, that is you. That's on your end. This coming across at 1080p with no sticks. So if it blurry on your end, you could fix it. You could raise the quality. Well done, Colin. Well done, Janelle. Well done, Chrissy. All you're doing the thing. Are you ready for them? So Colin even write it out with that explanation. He said that the angle has to be 150 here because if I draw POR, right? Well, I have this angle here, but that's reflex. They didn't want the reflex angle. They want this angle. That's the obtuse angle. And this angle must be 150 degrees. And the reason why it's 150 degrees, the rule that we're using is that the angle at the center from the same chord is twice the angle at the circumference. That's another rule, right? So once again, go and revise your rule. So like, seeing that we got a 75 here, the angle, when you pull it from the same chord down to the center, it doubles. You understand that? Rate out of 10 how much you understand this question, and if you're ready for circle theorems, if some of you are for certain doing exams on Tuesday, maybe some of you are doing English tomorrow or whenever. English is tomorrow. When is English earlier? What's the next topic? What's the next topic we've seen in the house here? Practice on algebra. We just do some algebra coordinate geometry. Let me see if I can pull a coordinate geometry question from this paper. Is there coordinate geometry in here? Yes, there is a coordinate geometry question. Does exist here. This paper that I'm pulling from is January 2020. So what, 2 years ago? Wow, 2020 is 2 years ago. Unbelievable. Unbelievable. Room for improvement. The graph below shows a straight line intersecting the x and y axes. Using the graph, determine the gradient of the line. So how you do this? Write in the chat how you're going to find the gradient of the line here. So there's some coordinate geometry revising. Somebody tell me functions. All right, I'll do that next. Live right now. So in the chat, explain to me how you'd find the gradient of this line. It's actually very easy. Why is you all doing that? My desk real untidy. I didn't really clean up anything for the new year, but how we can live. A little status on the gram there and say alive. Feels good to teach. It's been a while. Live right now. Well, yes, the gradient of a line is y2 minus y1 over x2 minus x1, but you're not explaining to me how we're going to get like the what we doing. Choose to Alex get 2 points on the line, the thinker mashing it up. Alex gave me that's what I meant now. Let me just see if I could kind of like YouTube something here. YouTube. And I'm just trying to post a status here. Yeah, coming, you know. And boom. So choose 2 coordinates. The best coordinates to choose would be this one and this one, because I mean them easy to read off. This is like 5 on the x, 0 on the y. This one is what, 4? Like 2, 3, 4, 5, 6. So that's 4. 4 4 on the y, so it should come second, and the x would be 0, so 0, 4. So now you can say like this is x1, y1. You all with me? And this is x2, y2. So therefore the gradient is 0 minus 4, and what is this? 5 minus 0. So this is negative 4/5. You all got that? Why isn't it chat if you agree with me there? That's how you'd find the gradient of that line. And there's more to the question. Let's get the next part of the question. Tell me if that's making sense. Now the line is going down, so I expect it to have a negative gradient. The next step that I want you to do is find like the equation of the line. And there's two main ways to do this. Now, if you search Cohen Springer coordinate geometry, that topic has been trashed out on my YouTube. So you can get that. And in class, we come into this. Those of you who in my paid online classes are coming up to this real fast. This year going to be a movie. Yeah, you could use y equal mx plus c. So you could, this is one method. You could use y equal mx plus c. And we know what? What do we know? We know like our y, and we know our x, and we know the m. So you could substitute, find for c, and then pay it back. Or either using the big man approach. You could use this formula. I gave you all this formula. Y minus y1 is equal to m into x minus x1. A nice formula for the boys them. And you can mash up that there too. So, and you would be substituting like one of the coordinates here and the gradient, and you just boil it down. So let's try both methods and we'll see what happens here. So let's say I use the point 5, 0. So this is like x and this is y. I'm using this 0.50 from here. Remember that point over there? So I would be, and remember the gradient is negative 4/5. You don't just put it up for me. So this is like 0 is equal to m is negative 4/5 and x is 5. You understand that the 0 came from the y and the 5 came from the x. I'm just substituting plus c. So this means negative 4, because this will cancel, plus c. So c is equal to 4. Because if I bring across the 4, watch it good. If I bring across the 4, it turns to positive. So c is equal to 4. So if c is equal to 4, therefore, this equation of the line must be y is equal to m. The m and the c need to be substituted when you're putting the equation of the line, right? So the m is actually negative 4/5 x plus 4. Why isn't it chat if you agree with that? So this is one way you can do it. Or you could do it and mash up the dance. Another way is you could just like substitute directly. So you could put like y minus 0 is equal to m is negative 4/5 into x minus x1 minus 5. So what substituted here? What this 0, boom, this negative, this 5, sorry, 5, and this negative 4/5, right? And then y is equal to negative 4/5. X minus 4/5 has to come and multiply by this negative 5 like this. You got a little cancellation here. The sign will switch up on you, and you get y minus 4/5 x plus 4 again. So same thing here. Coconut Ramco gas. Yeah, so there's even a faster way. This is a 1-mark question. There's even a faster way. And Shady Brown is spotting the faster way. Big up yourself, Brown. If you watch the line, you already know that the y-intercept is negative 4. The y-intercept, positive 4. Javish, was he seen, brother? The y-intercept is 4. So you know the y-intercept, you know the gradient of the line from graph. Y-intercept. Javish, I wish math was like this forever. Y-intercept is equal to 4, and the gradient is equal to negative 4/5. Therefore, y is equal to negative 4/5 x plus 4. So this is another way you can do it, basing your stuff from the graph. Well done. What you all think about that? How are your coordinate? You all ready for coordinate geometry? Is there more to this? Yes, there is. So they want you to find the equation of the line that passes through P, but it's perpendicular. Let me show you. Equation of the perpendicular line that passes through P. So P is where, boy? P is over here. So let's say there's a line that's perpendicular. That wasn't supposed to happen. Let's say there was a line that's perpendicular. I don't even know how that happened. I need to research that. So there's this line that's perpendicular. They want you to find the equation of this line. But you kind of have everything you need to know already, yeah? I feel like I have everything you need to know. One, you already know that if this intercept at 4 here and this pass through this point, this would -4 would be the y-intercept there. You kind of into, I mean, you could go ahead and find that, but with that, you could figure out the answer will be y is equal to invert this switchy sign 5/4x minus 4. So that's what you're looking at in your mind. So that kind of mental question. But let's try and do it how they would want you to do this so you can do it in any situation, right? So since line is perpendicular, since the line is perpendicular, yeah. Perpendicular lines, the gradient, let's call this M2. The gradient must be equal to the other gradient in this formation. So this is the formula that you want to take, and we call it the negative reciprocal. So you put M2 should be equal to -1 over -4/5. So the gradient of this line, M2, is 5/4. It's like you flip it and you switch the sign. So you have the gradient of the line. We also have a point on the line. The point is P, 50. So P is 50. So we can find the equation of this line very easy now. Let's use the y minus y1 formula. Y minus y1 equal m into x minus x1, where we substitute in the y1 and the x1. See them there? And we substitute in the m. So y minus 0. Hold on. Let me make sure I do the correct thing just now. Yeah, we had used this point, 0.5. Yeah, we didn't do the correct thing. So y minus 0 is equal to m is 5/4 x minus. So somebody is asking when this is 5/4 x minus 5. Oh, I was wrong. It doesn't. The y-intercept would not turn out to be. So this turning out to be 25/4. Yeah, that makes sense. The gradient wasn't like 1. If the gradient was 1, it would have been equal this way and cut there. So it cuts it a little different. Then he's asking, when does y equal mx plus c apply? I'm not too sure I understand the question, but you could use y equal mx plus c to find the equation of the line. It must look like this. Y equal mx plus c, and you substitute what you know to find c. And once you find c, you write it back with c and m written out. But you put the y and you put the x. That's how it works. Just practice it. Practice it a couple of times. So, like we did. Now you can leave it in as improper fractions. I see some people put 5/4 x minus 6.25. An extra thing in my book. But we don't really deal up with decimals too much in these straight algebra. Which was the next thing you all wanted to do? Oh yes, I said functions. Functions. Let me see if I could pull out a functions question here. Talking to the moon. Yeah, we have a nice little functions question here. Traditional. Oh, I do this in my class recently. Yeah. I do this with the class. I do this in my class. That's why this is looking so familiar. Best calculator, search up Kerwin, Springer, Casio. Mix is a question, boy. Anyone here get location relating to where you're doing the exam, you're supposed to go on the website or something and get a, or you talk to the man that way. Please do cumulative frequency. I'll see if I can get something on cumulative frequency for you. Maybe I'll explain cumulative frequency. If you've seen it blurry, you need to change these settings. Anybody out there seen it blurry? Change these settings on your end. So sometimes this pops up and people doesn't know what to do. If this pops up, look for the denominator and find when the denominator is equal to 0. Because if the denominator is 0, you wouldn't be able to divide by 0. In maths, we're not allowed to divide by 0. Type in something in your calculator and press divide by 0, problems in the dance. It undefined, or you get math error 2 on your calculator popping up. So undefined when 5 minus x is equal to 0, or when minus x is equal to negative 5 when I bring across the 5, or x is equal to 5. Drop the negative from both sides. So that's the value of x, which is undefined, 1 mark, collect it. But that was the hard part of the question, as 1 mark. The next part was to find the inverse. Now this is the hardest inverse you could get for CXC, like finding the inverse of these kind of functions. And the reason being is that you have two x's here, x there and x there. And that's caused a little problems for people. So h of x is equal to 2x plus 3 over 5 minus x. This is what I tell you. This was January 2019 or something. So how we doing this? How we getting the inverse here? What's the first step? So the first step that teach in school, I saw now custom using glasses. Glasses people always make out by. This thing is just collect dust, collect fingerprint. Not to mention it fogging up, let h of x equal y. Is that do this in school? And y is equal to 2x plus 3. Now you can search inverse, or you can search functions inverse, Cohen Springer functions inverse. You'll get the full lesson on this. I'll probably write in down topics and remember. The next step is to interchange variables. I see somebody put in the chat, switch x and y. Here's a nice word you could use, interchange variables. Look a little big out in the dance now, man. So you put x here, and anywhere you see x, you put y. And the final step, well, kind of like the final step, is that you want to make we till use our massive glasses here. All that thing is blowing up. Make y the subject of the formula. Now, this is the part where students struggle with, and CXC always bring in this. So they always bring in these ones. If it was something simple like y equal 2x plus 3, and you need to make interchange and then make y the subject of the formula, that easy. There's just one variable. But this has, sorry, there should be a y here. This has two y's here, you know? Yeah, thanks, Jamie. This has two y's here. So getting them to boil on to kind of merge to one y is give even top students little problems if they don't know what to do. So let me show you what to do. So if it pop in the exam in 2 days, you know what to do, right? So you bring across the denominator, 5 minus y is equal to 2y plus 3. Everybody should understand how this line came about. It's like you multiply by the denominator on both sides. Expand, you get 5x minus xy is equal to 2y plus 3. And what you want to do is keep your eyes on the y, on the prize, man. So all them y's, we want them on one side now, buddy. Understand? We got them on the left side. You understand what happened here too, right? I expand the brackets. We got them on one side. So let's get this across here, and let's bring this across there. Visualize this with me. You'll have the negative xy. When you bring this across, you get negative 2y. And when you bring this across, you get 3 minus 5x. That good? Look, Alex gave you a little tips there for anybody who getting problems to see the timetable and thing. I'm gonna leave it up for a little while. All right, enough while. So negative xy minus 2y equals to 3 minus 5x. The y is there. Keep your eyes on the y. This is a 3-mark question. That's a good bit of mark for a question. And to get the y to come out as 1y, you're going to do something we like to call factorize. So you'll have y into minus x minus 2. That way, normally you don't have two negatives, but okay, fine. Got two negatives. This is factorizing. Is equal to 3 minus 5x. We're nearly done. So y is equal to 3 minus 5x over negative. Yes, all lives are always safe once it's public. Once nothing drastic can happen in your life. So therefore, The inverse is 3 minus 5x over negative x minus 2. Now, depending on what you do here, some people might get it to look like this. They might get 5x minus 3 over x plus 2. If you have that, that's also correct. That just means like maybe you brought the y's across onto this side, like you brought this y here, and you brought across this 3, and then you bring it down all the way. So both of them is correct. If for those of you who really good in maths, you'll probably realize that this is just like multiplying by -1, top and bottom by -1. All right. So that is functions. What next? What other topic y'all want me to touch on? Just call the topic and we touch on it again. Oh, somebody said cumulative frequency. Cumulative frequency, right? That is statistics. I wonder if it's a cumulative frequency in this paper that gonna make my life easy. Otherwise, I gotta pull it out of my mind. No, they're bringing pie chart real plenty these days, but you got oh god. A cumulative frequency could really come on Tuesday, no? A cumulative frequency could really come on Tuesday. So cumulative frequency, what you should know, I have a whole video on cumulative frequency, but since I'm here already, cumulative frequency is a graph that has come out so by. And this thing, by the way, is called that. This is a question is asking multiple choice. Very likely you're going to see this in a multiple choice on Tuesday. And here we have the cumulative frequency, and here what we have by whether a continuous, some continuous data. So let me give you an example. And this will carry across a good few topics. Let's give you like maybe a few categories. So let's say this is like the height, or let's say maybe age. Yeah, age is an easier thing to use. And let's say this is the frequency. And this is the cumulative frequency. Now, they would just give you this, but they wouldn't give you this column. Most of the times, they really give this column, right? So they might have something like, let's say, I don't know what to write. Let's say 5 to 9, 10 to 14, I'll try it here, 15 to 19, 15 to 19. So what you call these things? What's the word for these things? It's 2 words. Something, 20 to 24. Let me actually break. No, we can hit them at one more. 25 to 29, right? So let's say the frequency went something like something like maybe 4 6, 10, 15, 4, 8, 15, 10, 3. Let's make it something like that. 3, yeah. Okay, so yes, you actually call these the class intervals, and there are lots of words here that you need to know the meaning for. So the thing itself is called the class interval. So like if I tell you what is the 4th class interval, 20 to 24. This number here is called what? This number is specifically called what? What is that number? What is this number? So what's that number? What is this number? What all these numbers are called? What are all these numbers called? So this one is actually, and some people probably put it in the chat right now, but there's a slight delay in my chat by the time somebody said range and rather no. Right, so Caleb is using the word limit. So it's limit. So these are the limits. So these are the lower class limits, and these are the upper class limits. So these words we use here is limits, right? Are you with me? So these are the limits, and there's also something called the boundaries. The boundaries are not shown, but they're important. They're important when you're doing histograms. They're important when you're doing cumulative frequencies. So the boundaries actually is the number that's between the upper class limit and the lower class limit of successive class intervals. Understand? So the boundary here, now let's put it hidden, crouching tiger, hidden boundary. And that might be like a 9.5 there, all your vibes in there, and this is like a 4.5. And then 9.5 will repeat itself here. So the boundaries is like the line. So if you use 9.5, you actually belong to this one. But anything under 9.5 in this one. Understand? This will be like 14.5. Why isn't it if you understanding what happening here? 19.5, 19.5, 24.5, 24.5, 29.5. So you're catching the vibe. So when you're plotting the cumulative frequency, you know which one of these soldiers you're going to use? You're going to use this. And if you don't know that, you just lose max one time. Bye max. Goodbye max. You just lose max one time. So you're actually using the upper class boundary when you're plotting cumulative frequency. Somebody could just double check that and make sure I'm talking sense. You can check it on one of my videos there. When you're using the class, so you're using the upper class boundary when you're plotting cumulative frequencies. When you're doing the frequency polygon, you want to use the midpoint of each of them, right? The midpoint not shown here would be like add this and this and divide by 2. So that'll be like 7. The midpoint is 7. But don't use the midpoint for cumulative frequency. All right. So what is the equation of the line of symmetry? So this comes out in completing the square. If you want, we could do a completing the square question next. So anytime we talk about equation of the line of symmetry, normally they're talking about completing the square. So we talk about that next. So what you're supposed to figure out with cumulative frequency is this column. And that works by like 4 and 8. So all right, you start off with 4, and you say 4 plus 8 is 12. And then 12 plus 15 is 27. You understand? 27 plus 10 is 37. 37 plus 3. Oh, good. I just get at it. Like I really a maths teacher out here, right? Let's get a nice sweet number there, 40. So normally when you do your cumulative frequency, this number is the combined frequency of everything. Normally it's come out to like 15 CXC or 100, but it don't really matter, or 60. It's just how much things in the survey number. So that is really, and how do you draw the graph for this? Well, not drawn to scale. Not drawn to scale. Let's do this graph. Zap. Zap. All right. Thank you for your services. So what you want on this axis is your cumulative frequency. Good old days area. Hell, I wish maths remain like this, and or maybe not. I could real draw this on a line by Cohen by. Anyhow, let me ignore that. So let's say this one here was 10-ish. So we can be kind of guesstimating here earlier. 20. Don't do that in your exam. Use proper thingies. 40. And what going here? Right? Oh, age. So this going up to like 30. So like 30, 15. Okay. 5, 10, 15. Right. So let me say maybe 5, 10, 15, 20, 25, 30. Keep in mind when you're plotting these things, no, not the lower limit, you're using the upper limit. So this will be like 9.54. Hell, everything good, boy? 9.54. So you come to 9.5 and you figure out where 4 is, and that's the first point there. Just like that. Now, you couldn't, in some cases, I've seen CXC extrapolate this down to the next boundary here. So that's like that. So it kind of depends on what the question I'm working with, right? Because if this is your total number of people in the survey, it means nobody else was included outside here. So you could bring this down to 0. All right, 12, 14.5. So 14.5 is just before 15 number, and 12 looking like about here. So boom, let's keep all of them, right? Thing. And next one goes up to 27, guys, and at about here. So you see we get the curve to kind of curvish, and 37.5 with 37 with 24.5. 24.5, 37 would be about here. So next one finishes off nicely at 40. So your final curve will come out like this. Like you day. Nice you day. So you're always getting this kind of S thing, because what's happening is the data is normally be skewed towards the center. So the data skewed towards the center, the gradient is kind of speed up in the center and then ease up on each side of the graph. But this is how your graph should look. And what CXC would ask here is quite a few things you could ask here, boy. Why we saying why? Why just mean yes? What kind of questions you all think they could ask you here? The most common question they ask you is for Q2. What do you think Q2 mean? There's Q1, there's Q2, there's Q3. Of course, there's Q4. Yeah, they could ask you the upper quartile. When they say in the upper quartile, they're talking about this guy here. And when they say in the lower quartile, they're talking about this solar here. Crispy? Yeah. All right. You can lock back the door. Yeah. When they're talking about median, yes, well done. Well done, Razak. So median, they're talking about this guy here. So this is the median. This is the lower quartile. Why isn't it chat if this is the first time ever heard this before? And this is the upper quartile. And don't worry about it. Don't worry about it now. This is just the ending of all the data. Like, so this will be like 40. So the lower quartile, median, and upper quartile. The median just means, well, you know median from primary school. Median is like middle. That's like the middle. So in this case, it's 0 to 40. So you could say 20, or you could say 40 plus 1. You normally use that add one thing for odd data, but if you use 20, you get it correct. If you use 21, you should get it correct as well. No, 20.5, sorry, because they have 40. So sometimes the formula for Q2 is n plus 1 divided by 2 now. You all ever see that before? So like n being the total number of things that we have, so this will be 20.5. So your median will come out from like 20 or 20.5. Smack it here and then go down. Boom. So the median is the number that reads off here. So let's say this number was 16.5. The median age is 16.5. They can ask you, somebody said it, semi-interquartile range or interquartile range. They can ask you for those things. If you ask you for the interquartile range, you need to find Q3 and Q1, and minus them. So that's the upper quartile and the lower quartile. Quartiles just split the data into 4 parts. So like, if see how this is 40, the upper quartile is like, the top will be like 40, the upper quartile will be like 30, and the lower quartile will be like 10. Understand? Or you could say n plus 1 divided by 4 for the Q1. You take this long if you want. Divided by 4. And for Q3, it's 3/4 of n plus 1. Or 3 times n plus 1 divided by 4. But as I said, this normally works best with odd number of things. When it's even, you can just divide by 4 or 3/4 n. It dab a little is still because I see different things in textbooks and things. But basically, once you see you're getting quarter of the data, so like 10, bring it down. Who is that there, boy? What he looking like there, boy? That looking like 13 to me. And 30, smack the graph, bring him down. That looking like I could ratchet that to 20, you know. All right, let me make it look like 19. I just sweeten the pot. Maybe I was a little too high. Let's say this is 19. So we found Q1 to be 13. Right out of 10, how much you'll understand in this. And Q3, you could always look up cumulative frequency. Yes, of the top of the Aidan. So you're kind of thinking But don't say of the cumulative frequency, we more mean of the n. N is the total number of whatever it is. Like this had 40 people in the survey, total number of people in the survey. So you could always look up Kerwin spring and cumulative frequency for the full lesson on it using a past paper. So how we have Q3 is 19. The interquartile range would be 19 minus 13, which is 6. And the semi-interquartile range, the SIQR, would be the interquartile range divided by 2, which is 3. That's it. So this is about all they could ask you. The only other thing they will ask you on is like probability or how many people are under. So let me bring the trickiest one. What is the probability of selecting random, of course? So randomly selecting a person 19 years and older. Now, the reason I use 19 is because we already know what 19 lines up to. So it can be easy for me to explain. Maybe about 3/4 of the times they bring under. Under is always work out easy, but when they say over, people just forget to do something. So that's why I use that. Years and older. So sometimes I just leave out probability and just ask you something like how many people are over 19 years or something like that. And it would come from 19 and come to 30 and realize there's just 10 to make it up. That making sense? So if they ask you for the probability of selecting a person 19 years and older, you need to find how much people 19 years and older. So you come on 19, you go straight up, and you come straight across and you get 30, right? And you realize there are 30 people under 19. So how many people are over 19? 10. There are 10 people, ignoring 19, over 19. So therefore the probability for 19 and over would be the desired sample, the desired outcome over the total number of outcomes. So it's a quarter. Now you can write your probabilities as fractions, as decimals, or as percentages. If they say percentage probability, for sure go down to percentages. But normally I always tell my students to kind of like finish off with percentages for probability. But probability could be written as, like in pure maths, is real, stick the fractions with probability. So you can do your calculations fast. But that's about the hardest thing you could ask with cumulative frequency. That's cumulative frequency in a nutshell there. What's the next topic you all want me to do? Another topic you all want me to refresh or review? So what's another topic, guys? Well done, Hannah. So far we did, let me see what's the first one. Transformation. All right. Transformation. This is first of the bottom. First come, first serve. All right, so transformation. So transformation in the syllabus. Transformation. By the way, if you're doing maths in May and you want to join our online class, come join the best. The number to WhatsApp is 472-4221. If you're not in Trinidad, 868. It is plus 1-868-472-4221. WhatsApp, talk to the admin, join up. The student has classes in all C-Sec subjects, all CAPE subjects, everything. You can just like yourself. All right, so transformation. Transformation in the exam comes either in the basic or in the advanced approach. No, I just separated into these two topics. The advanced are really talking matrices and vectors. And basic, we just talking like what could come like in section 1. So I'll try to cover everything in like a quick lesson here, right? So in the different types of transformation that could happen, you all could tell me the different type of transformations. We'll go through all of them. I think it's 4 we have. Yeah, it's 4 we have. And well, there's a special, which is like, let's say a combined transformation. So there's 4 that comes to CXE. And so we'll do the basic stuff. And then we talk a little bit about matrix transformation. Crispy, you have a formula book open anyway that I could just show these people. And vector transformation. So yes, very good, Hannah and Brandon and Colin. So the 4 main types is rotation or rotation, reflection, aka flip, enlargement, and translation. Most common, so this is that, right? The most common, this could combine to give you any one of these. But this is like the advanced. You have a formula booklet anyway that I could just bring from you, Crispy. And this is the basic. So you can look at all of these from like an advanced perspective using matrices, and that is really rare. That's be like one of the, like maybe the top 5 hardest things in CXE, matrix transformation. Vector transformation, that's easy. That's a glide or a glide. Some people is called this glide and slide and all kind of thingies. So rotation, reflection, flip, enlargement. These could come simple, or they could come using matrix transformation. And then you could do a combined transformation, which is a combination of these things. All right, so how does the rotation work? For rotation is the most, I don't want to say complicated, but it's the one where you need to say the most amount of things. Remember this. So if they give you a rotation and they ask you to describe it, for example, if they give you something like this. Now, everything I do has a strong exam pass paper vibe, right? That's my thing, preparing people for exams to pass. That's, if you watch your channel, it's just that, right? So what I'm giving you here is good thing. So let me say you had this triangle here. And they call that triangle PQR. And then all of a sudden, you have a formula booklet open anyway. Yes, seeing PQR doing a kind of thing like this now. PQR. Now, this is a trick. This is a trick of the enemy. So, and they ask you, what type of transformation is this? It looking flippish, mirrorish thing, right? So we'll use this book. This is a booklet I made with all the maths formulas in it. As I said, it's available in Mohammed's bookstore in Sour, Mohammed's bookstore. You should go on as it's available in a bookstore in Point 14 and thing. But if you want to, you can just WhatsApp the same number right here. Anyhow, so it looks like a flip. It looks like a reflection in the x-axis, but it is not. This is actually a rotation, and what you need to pay attention to is the points here. So think of it. It's like if this side was PR was red, all of a sudden PR is here. So it rotated. It didn't flip. If it flipped, then PR would have had to be like this. This one would have had to be R, and this one would have to be Q. So it flip. But that didn't happen, right? So this is PR here. So that's and with rotation, there are 3 things that you need to state. 1, 2, 3. Well, I think it's 4 actually. So you need to say that it is a rotation. That's 1. So you state it's a rotation. You state the center of rotation. Center of rotation is the origin, which is 0, 0. Most of the time is the origin. 99.9% of the time is the origin. The third thing, you need to state how much. So 1, you need to state that it's a rotation. You need to say the center of rotation. You need to state how much. What I mean when I say how much degrees? So 90 degrees. And the last thing, remember they said it's going to save you the max, is the direction. So the direction is read anytime. What is that boy? Clockwise. And with this, you will get all the max. And when they give you a rotation in the basic form, it's normally always this they're asking you to do, to describe the transformation from this to that. There's a rotation about the origin. So in a sentence, this is a rotation of 90 degrees about, I'll put clockwise here. Clockwise rotation of 90 degrees about origin. Boom. In a sentence, I state all the 4 things. Why is in chat if you understand that? So that's rotation. What the hell? that's rotation. Reflection. What's the next one here? Reflection. Reflections in CXC. Reflections in CXC, normally easy as well. Now, maybe about 80% of the time they like to reflect in axes. So let's say we had this triangle here, A, B, C. All of a sudden you will be seeing something like this. Tell me what's going to go here if it's a reflection. 1, what is 1, what is 2, and what is 3? If it's a reflection in the y-axis, what is 1, what is 2, and what is 3? So somebody asking if you need to stay the axis you're rotating on. If you're rotating on an axis, you'll make a 3D object. That is admath, that is integration. So for example, if this triangle rotates about the axis here, you know what's going to happen? It's going to form a kind of triangular ring, but I can't even draw it. That is going to form a 3D object. So you don't rotate about axis in CXC maths, you rotate about a point. The center of rotation, right? So don't mix up them words. The axis, if you reflect, you can reflect on an axis. So this one will be B and not A, because this one is close to, let's say this, actually this looks like the axis of reflection was about here. So this one will be A and this one will be C. Now, when they're doing these things in transformation, they like to give a little touch up on the top right there. So that's prime, not complement, prime, B prime, A prime, C prime. And the name of this line might be maybe like x is equal to 2 or something. It depends on what number it cut, not x, y. Y is equal to 2 because this is on the y-axis. So let's see that number was 2, y is equal to 2 is the axis of rotation. So reflection. So when you're defining reflection, you need only to define a couple things. 1, you say that it is a reflection, and 2, you just give them the axis. And it's normally the equation of a line. If the reflection happens on an axis, like maybe, let's try, if the reflection was on the y-axis, it would have come out like this. You all agree? A here, B here, and C here. So this will be double prime because we already have our image. So this will be a next image. And this will be a reflection about the y-axis. And as well, a reflection about the y-axis. Or this one is a reflection about the line y is equal to 2. So some people are asking for equation of the lines. Now, we did coordinate geometry, a little revision, and it just now, like, if you have C here and you have the gradient, you have y is equal to mx plus c, and you get some kind of thing. So we do something like 5/4 x minus 4 plus 5 or some kind of things, or minus 5, right? But these lines that they're reflecting on are normally horizontal lines or vertical lines. Let me just give you something, because this will confuse a lot of people, especially if you're medium to lower level in mathematics. This is confusing the hell out of you. So if you have a line here and this cuts at 3, the equation of this line is y equal to 3. That's it. You don't need to study about no mx plus c or nothing. If you have a line and vertical and it cut the point like maybe at 5, the equation of this line is x is equal to 5. What it's basically telling you is anywhere along this line, x will always be 5. Anywhere along this line, y will always be 3. That's the equation of the line. If the line itself is the axis itself, well, then this is the line, the x-axis. No equation of this line. Or the line y is equal to 0. The x-axis is known as the line where y is equal to 0. Or similarly, the y-axis would be known as the line where x is equal to 0. Although it's the y-axis, it's along the y-axis, x is always equal to 0. Are you catching that? So like you need to know this to be able to state the line of reflection. So if this was a line here and it cut 2, you'd state the line of the equation of the line of reflection is y equal to 2. A big up Deja Munsami. And y-axis, this will come across here. All right, so that's reflection. What's the next one? Enlargement. Enlargement for CXC could come in 3 ways. It could come straightforward, like an enlargement of like times 3. It all depends on the scale factor. You could just check and see. It all depends on the scale factor. So this is like a normal scale factor of like, let's use an example. I'll just use the example 2, yes? And then it could come with fractional scale factor. And this will be like example. Let's use the example. I want to use the example of half, so you had to be at 3 now. And fractional scale factors, these are not really enlargements. These are the opposite of enlargement. Have you figured out what that word is there, boy? What's the opposite of enlargement, boy? Teach maths. Yeah, it's still under the topic of enlargement, but the opposite of enlargement is reduction or something. Scale factor, right? And then it could come with a negative scale factor. All of these can come. Like let's say -2, right? What you will do in that case. So let me show you the 3 examples on a graph. 3 examples on a graph, so you can fight. You can make a little fight. Edisha. Blessings to you, D. Small shrink. The opposite of enlargement is small. They still call it an enlargement. Yeah, you can still call it an enlargement. It just with is an enlargement with a scale factor of half or something. All right, so let's do the 1. The 1 is the easiest. Number 1 is a situation like, let's say I had this triangle here, boy. Right? Now give these ones points to kind of help out the situation. Let's say you had a triangle looking like this. And let's say this point was, what point that looking like? Boy, that looking like the point 2, 6 or something. So this would be like 2, 2. And this would be like 2, no, not 2, 5, 2 or something like that. So in a reduction, we diminish reduction, go work. Let's say the center of enlargement was the origin 0, 0. And you're using the scale factor from the example of 3. So what you're going to do is, there's a way to do it geometrically with measurement, or you could work it out by multiplying these numbers by 3 if the center of enlargement is 0, 0. The way to do it with geometrically is like you draw a line, right? And you see the distance from this to this, you measure it with your compass, and then you just cut, make one, and then you make a next one there. That's one point. Then the same thing happens with this. Cut, cut, cut. That's the next point. You understand what's happening there? It's like you're doing an enlargement of 3. So 1, 2, 3. 1, 2, 3. Same thing will happen with this point. Um, 1, 2, 2, 3, somewhere there. Y'all catching this? Y'all catching this? So this is your new triangle. If this was like A, B, C, this is A prime, B prime, C prime. And obviously this would be 6, 18. Oh, 6 times 3 is 18, eh? It's been a while. 6, 6, and 15, 6. So is 99% the original do the enlargement from. If it come from a different point, just do the same thing. Draw the lines, measure off. If it's a scale factor, it's either a scale factor 2 or 3, they wouldn't really get anything else in terms of this normal style. So this is the scale factor. So this is number 1. This is a scale factor of, it all depends on what the scale factor is. 3. If it's a scale factor 2, then it would be somewhere here. So you catching it? If it's scale factor 4, then it would be somewhere here. So you'll see what happening there, enlargement. Now something weird happens when the scale factor is a fraction. That's called a reduction. So if I started off with maybe a triangle like this, or maybe a triangle like this, and I had the scale factor of a half, what would happen is that I bring it back to the origin, if that's the center of enlargement. And instead of doing like 1, 2, I'll have to divide this by 2. And that would be my new thing. That making sense to you? So I come in halfway between all of these, and my new triangle would be here. And this is a reduction. So if this was A, B, C, this is A prime, B prime, C prime. No. So Vapor accent like -2 would be a reduction. No. They bring this already, and plenty of people do this. This is a scale factor of a half. That's no negative here, you know. A half. If you have a scale factor of -2, which is the third thing that could happen, the weirdest of the weirdest thing happens. If you have a scale factor of -2, watch what's going on here. So the first triangle looking like this. A, B, C. A scale factor of like -2 would carry this. Well, it's still 2, so it's still enlarged. Oh, geez, I'm trying to draw that line straight, my brother. It still would make it bigger. It still would make it bigger. Like this is the triangle, it'll still come out twice as big, but it will flip and come in the next side of there. Real wildness. Real wildness. So you're gonna get something like this. Oh, it can look too wild. Y'all understand what happening there? Let me get the points. Like if this point was 3, 3, and this point was like 3, 7, and maybe this was 8, 8, 3, and this point across here would multiply this by 2, but -2. So you'll get like -16, -6. This came already. So this is what you do if the scale factor is negative. So scale factor of negative, this one is -2. So take a little note of these things. So this is C prime. No, what is this? This is B prime. So this is B prime. This is A prime. This will obviously be -6, -6. This is C prime. This will be -3, -14. So it's still doubling, but in other words, the scale factor is something is take and multiply the original numbers by. The original number was 26, multiply it by 3, you'll get 2 by 3, 6, 3 by 6 is 18. Right? I didn't write the numbers for this, but let me see this one was maybe, let's say this was 4, 8, then you half this and you end up with like 2, 4. Understand? So yeah, this video would remain posted. So that is enlargement. Finally, translations really and truly don't come in the basics so much. If you come in, because it kind of real childish to talk about a translation. It's like an essay thing. Essay come back again. I'm sure what translation is. So if I have the triangle here and I want to translate this, I'm going to create some numbers. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7. This is translations, guys. 1, 2. All you press like on the video. You might have to close the live chat to get to the like button. Press like on the video. How long we live for? 1 hour and 12 minutes already. My gosh. That 1 hour and 12 minutes real fly by. So what is this point? Let's say this is A, B, C. This is 1, 5. This is 2, 5. This is 2, 8. And let's say we want to translate this. With translation, you normally interpret it using vectors. But you could talk about it without using vectors, I'll show you. But you have to translate it like, let's say, I don't know, boy. Let's say 4 -3. So we don't write it like this. You actually write it like before here and the -3 like this. So you're using that vector to translate this or slide it or glide it or however. The 4 just talks about the x. This talks about the y. X is the horizontals and y is the vertical. So if you're translating this 4 -3, it means you need to move it across 4 and then move it up or down 3. Now, because this is negative, you're moving it down. If the x was negative, if the x was negative, it means you'd have to go to the left. Without that, I'm actually understanding everything in transformation so far. Now, once again, you could search Cohen Springer transformation and you could get the 1,000,001 videos I have on transformation already. I mean, it's a real topics here. Now, if you're the full long thing and you're doing exams in May, you could just join my class and you get a whole class length explanation, talk, homework, corrections, everything, right? So this is literally like if you're moving this across 4, 1, 2, 3, 4, then you're moving it 3 down, 1, 2, 3. So you're going to end up somewhere here. Right? It's going to end up 4 across. So think of like if I add 4 to this and 3 down, think of like if I take away 3. So this will be 2, 6. So 6, 2. This B is going to look for himself and find himself here. So A is going to find himself here. So C is going to find itself there. So the new, where my thing's gone? All right, it'll come back. New triangle will look like this. So you're catching this, right? This is a fairly easy topic, B prime, C prime. And you can put in your coordinates here. It's to work it out. Let me just go in how you work it out with vectors. It's like A plus the transformation vector is equal to A prime. So you're adding on the vectors. So it's like the A coordinates of A is 1, 5. Let's put it in this format, plus 4, negative 3. So the coordinates of A prime is going to be 5 and 2. You see that? 1 plus 4 is 5. 5 plus negative 3 is 2. So that's how we know that this is 5, 2. Similarly, this one will be 6, 2. And this one will be 6, 5. You could verify it. As you did. That's translation right there. All right, so let's go into the tougher side of things. I said, whoa, this was a big whole lesson here. I said transformation can come with these kind of basic ideas where you need to like define it and explain rotation, reflection, enlargement, translation, do a combination of these. Or it can come with the more complex ideas where you have stuff like matrix transformation. So let me see if any of these papers I have up have like a matrix transformation in it. That will make my life easier. No. None on this one, none in the Jan 2019 paper 2. I'm just pulling up one here. Wait. January paper 3. Oh, the 2020. 2020, where you seeing there, bro? Senior vectors there. Okay, so 2020 had one. And it looks something like this. I take out this blue light glasses and everything just look blue. The transformation maps the point R onto R prime as shown. This is a transformation matrix question. And notice this here is a matrix. It's a transformation matrix. Now, what this book is really good for is that it has all the formulas now. It has all the common transformation matrices on page 24. Let me just hit you the topic on this for now. This is how it goes. So, thanks. You have 1, 0, 0, 1. What is this matrix called? What is this matrix? What is matrix called? What is matrix called, Alia? What's so unique about this matrix? You multiply anything with this and nothing happens. So if you multiply any point, any other matrix, so that nothing would happen to it. This is the identity matrix. Well done, chat. All right, everybody know it. Razak, Shady Brown, Colin, Alana, Eden, Teshol, Saint, everybody, Silva, boom, bam, bang. Unit matrix could work too. That could work too. But the word we're using CX is identity matrix, right? So, for example, if I take 2, 3, and I decide to, hit him the identity matrix 1, 0, 0, 1. This is the only way I can put it. I can put it the other way around because I need to get the same number of columns in the first matrix and match the same number of rows in the second matrix. So you can check up matrix multiplication on YouTube and see what's going on here. The answer will still be 2, 3. This multiply would give me the 0 will cancel out 3 and I get like 2 plus 0 and I get that back 0 by. Yeah, check it out on matrix multiplication. What matrix transformation does is it, listen to this. This might, if this is the first time you're hearing this will open your eyes to matrix transformation and kind of how easy it is. It's one of the toughest subjects, like top 5, but the concept is easy. They're taking the identity matrix and they're just gonna it's like there's a drug dealer, and it's not the pure cocaine anymore that way. They don't let their parents hear what it's not they doping it with detergent or whatever it is. I don't know. I just talking from movies and things. Whatever they doping it with. So we're gonna dope the identity matrix, and that's how we create transformation matrices. So it's like yes, if you do one thing, like if you just switch the sign on that, something strange happens. All of a sudden, the answer will come out like this. This negative will go here, and again -2 here, and I get 3 here. So think of it. The original point would have been 2, 3, which is here. That's like A. And A prime turns out to be -2, 3. A prime turns out to be here. What we just do? What just happened here? This matrix causing a scene. This matrix causing a reflection in the y-axis. And that's one transformation matrix in there. So it causes the coordinate to reflect in the y-axis. And if you switch the negative sign on this side, and I add like a 0.23, it will end up with 2,3 here, but this will be negative. So A double prime will end up somewhere down here. This is a reflection in the x-axis. Catch it? And that's not all. You could do rel, you could do a whole bunch of wonderful things. You could, instead of switching the sign, you could switch the numbers, switch the zeros and the ones. So I could start off with 0 and do it like this. And what we had noticed happening is that the points will actually flip, and you get 3, 2. Let's call that A triple prime. And if the points flip like this, say the 3, 2, this is like 2, 3. So 2 would be here and 3 would be here. The new A triple prime will be somewhere here. This matrix, I don't know if you all know. Yes, Janelle know it. Janelle know it. Janelle, well done. You know your thing. You're ready for them. This matrix is actually and so cool. That's exactly what it is. This is a reflection in the line. So cool. Welcome to the notes. Yes. Welcome to the notes. A reflection in the line y is equal to x. That's that matrix. And all kind of weird things can happen. So like I could flip the numbers and make one of them negative. I could do that. You could, instead of flipping the numbers, you could change the ones into like a 2 or 3. This is a popular one. This actually causes an enlargement. Well done. So what I did is I have all of them in the book here. So you can always, those of you who have it, you can always just review it and have it up. So this question is asking us, R was the original point and it went across here using some kind of matrix. Now, if you have the book, you kind of know what this is. This is a rotation, and this rotation is happening 90 degrees and it's anti-clockwise. So rotation 90 degrees anti-clockwise, that is -0, -1, 1, 0. That's a rotation 90 degrees anti-clockwise. So you'd be able to figure this out even without doing the working. Will you catch that? How to figure it out if you don't know, if you don't have it memorized, if you need to show the working, if they're seeing 3 marks watching you for this question and you want to make sure you secure the bag, how to figure it out? Well, let me show you. when you're using the vectors, I don't know how many of you all noticed just now, when you're doing the easy thing. When you're using the vectors, what we do, we add now. So when we do the slide thing just now, we see the original point and we add the transformation vector, which was 4, -3, and you ended up with the new points. When you're using transformation matrices, you multiply. So what, I need to find back this thing. So, okay, let me show you what I mean. In this case, R is being multiplied by the transformation matrix M to get the new point. M multiplied by R will give you R prime. So when you're hitting a point, the transformation matrices are multiplication. When they give you transformation matrices, the main thing they're testing you on is matrix multiplication. Some equivalent matrices might come into play too. You could look up that. Let me show you what's happening here, right? So M was 0p q 0. What is p and q they use, or p and q? Yeah, we don't know what it is. Well, we know what it is because we had the book, but we don't know what it is according to them. R, we need to figure out R. R is 2, -5. You'll understand how I get that, right? I just watch the graph and I see 2 on the x, -5. And I know what R prime is too. 5, 2, 5 +2. From this, you can figure out P and Q. Let's see now, you can figure out P and Q from this. This is a topic called like equivalent matrices. For example, I can multiply this. So it's row by column, give me this one. So it's, stay with me, this is matrix multiplication. 0 by 2 plus P times -5 is giving me 5. I know a lot of people reaching maths, finish maths, reach up to CXE, and the teacher never teach you this. Is that if there's a topic that the teacher has missed out, this is like the most missed out topics. This three-dimensional trigonometry and linear programming, there's rarely for them topics. Students will always be telling me that right before exam. The next thing, you'll have Q times 2 plus 0 times -5. How many of you all the teachers teach this already? So it's 0 by 2 and P times -5 is equal to 5. And Q by 2 plus 0 times -5 is equal to 2. We could simplify this. We could say that -5P, because this is 0, right? So it's 0 plus -5P. So I can just put -5. And this is Q by 2 plus 0. So this is like 2Q must be equal to 5 and 2. And this is equivalent matrices. So therefore, the -5P must be equal to the 5. So P must be equal to -1. Well, 5 divided by -5 is -1. And 2Q is equal to 2. So that means Q is 1. Q had to be 1. That's the only way that can work. Q is 1. So we just figured out the values of P and Q, which we already know was P was -1 and Q was 1. P is -1 and Q is 1. And that was a question like 2 years ago. That was a question 2 years ago. That's transformation matrices there. So I teach you now transformation, matrix transformation could come in a whole bunch of different ways. I would advise you to go and learn all the different ways. That's just a little tip of the iceberg there. But you know the idea behind it. You know the rough idea behind everything there. What I just teach you was the idea behind everything. But it could come a little tougher than this. So what other topic? One more topic for the road. One more topic for the road. And then y'all could go and ramsackle the channel and learn any other topic that you want to learn by yourself. What was one other topic y'all wanted me to touch on? Just to get the revision rolling for some of y'all. Trigs, bearings. People always say bearings, and I had to take a breather. Bearings with a heavy hat. Bearings. Anybody had say anything on my Instagram? One person had say measurement. I do the other two things that the other two persons say. Bearings. Somebody say bearings too. Trigonometry. Look like we had to do bearings earlier. Oh gosh. Oh god. All right, bearings. Bearings it is. Let me see if I can find a bearings question. And then I'll teach you the basics on bearings. Problem in bearings, my your G's and H's. Bearings. All right, what they brought for 2020. All right, it was bearings. So let me do it. But they kind of drawed everything for you. Bearings could come real hard. And how it used to come back in the days used to be, whoo, how people sweating, but you used to get choice now. You could have picked which one you wanted to do. You could have picked your poison back in the days. Back in the days, that's 6 questions and you had to pick 2 in the section 2. Now, you're just getting 3 questions that you have to do. All right, so the diagram below, not drawn to scale, shows the route of a ship. I must do this question 100 million times, but I'll just use this question to show you the basics of bearings. Cruising from Palm City to, where's it called? Keaton? Keaton or Quayton? I don't really care. To Q, and then to Riverton. The bearing of Q from P is 130. So the first thing here, informative with bearings, boys and girls, ladies and gentlemen, men and women of all ages. The first thing with bearings is that you always take a bearing from the north. It's 3 figures, it's 3 digits, and it goes in a clockwise direction. All right, so let's say I had this here and that here, A, B. And I asking you for the bearing of A from B. You see this from? This from is oxygen. That from really important. Because the from indicating which one you need to start on. So if you hear what I said just now, I want the bearing of A from B. So when people say the bearing of A from B, they want to draw the north here and think like this is what they want. This is what they want. The bearing of A from B. That's wrong. That's real wrong. The bearing of A from B mean where is A located in relation to B. So you're actually looking for this angle here. So you start at the north and you're always going, where is this? Did I say anti-clockwise just now? Clockwise. You're always going clockwise. You understand? And you're stopping when you hit the line that connects A to B. If I wanted the bearing of B from A, then I'm looking at this angle here. All you need to learn, that's enough. And there's some videos I have on bearings that could help you catch your bearings too now. So go and catch your bearings with some bearings. Anyhow, so okay, the bearing of Q from P, so they start on P. And there's another way they could say, what's it's on a bearing of so and so to that. So if they say to, you need to check the first one. But if they say from, you need to check the one that comes after the from. Let me show you what I mean, because that must have missed some people. If they say the ship is on a bearing of 120 degrees, it's leaving A on a bearing of 120 degrees to B, well, then it's talking about this one. But if they say from B, then they're talking about this one. So I was saying, so to or from them, what is called that in English? Prepositions. To or from is what? Prepositions. Whatever them part of speeches, they're very important in this way. So the bearing of Q from P is 130 degrees, fine. And the angle PQR is 56, brilliant. Then they're going to ask you a whole bunch of questions. So what you're supposed to know with bearings, earlier, why is make bearings so hard? Bearings tests these things. It's like the strongest trigonometric vibes that they could bring in the exams, because it tests you on simple triangles and stuff like Pythagoras theorem and SOHCAHTOA. it tests you on these things. I don't know if you all know what I'm talking about. Transversals. What happens with transversals on parallel lines? Like if I have a parallel line here and I let a transversal pass through, this angle and that angle are corresponding. This angle and this angle are vertically opposite. They're equal. This angle and this angle down here are alternate. They're equal. So all of these angles that I'm shading in yellow equal to each other. And they are related to each other using terms corresponding, vertically opposite, alternate. Understand? Alternate, vertically opposite, corresponding angles are equal. Bearings test that heavily. Another thing you could know with this is this sometimes yes, your teacher might teach it like this. This angle and this angle supplementary. And you call this angle to this angle co-interior angles because they, they kind of enclose in the interior here. Co-interior angles add up to 180 degrees. Cool. So bearings tests on that. So it tests on those things, and it also tests on the heavy side of trigonometry, which is the cosine rule and the sine rule. Cosine rule and the sine rule. So you must know all of those things and be able to like spot it. Not only know it, but be able to spot it in a question to do bearings, which is why bearings is hit men out the ring and get them KO one thing. But let me see if you can do this question. Calculate the value of angle W. This angle here, tip, big tip for bearings. They do it here for you, but if they didn't do it, you want to always lengthen these north things and see it as two parallel lines. And then this is a transversal. All of a sudden, things start to look easy when you see that happen. You want me to say it again? The big tip for bearings is undo things here, right? Or redo. Okay. Right. The big tip for bearings, write this down. The big tip for bearings is to lengthen them north lines. And the lines connecting the points, think of them as transversals. We call them transversals. So line cutting through two parallel lines. And then start to use the rules. This angle must be equal to this angle, or maybe this one. Oh my gosh, we could figure out W. You're seeing it? You see now, it always start to pop out. Right, so every time you're seeing bearings, think about lengthening these two north lines and thinking of two parallel and the line cutting through. That's normally be the first thing to break the bearings question. After that, you get a hard cosine rule and sine rule to solve the other things. But the first thing to break the bearings question is that. And I think a lot of people seen it in the chat already. Since that is so, the angle, and I like to write it on the diagram. I might say, what the hell I can say, right? This angle theta, I mean, make it colder. That side of the room is made cold. I need to move to that side and I move a little to the side. Serious thing.
Yes, I think so.
Yeah. That's what I will do. But yeah, I'll do that between today and tomorrow. Anyhow, sorry for that interruption earlier. So it hot here. It means that 133 degrees is equal to 56 plus W. You all seen that? This 133 is equal to this. So therefore, W is equal to 133 degrees minus 56 degrees, which is 77 degrees. So what are we going to go this way? Oh, then we just wanted you to find W. So corresponding angles. No, those are alternate angles, sorry. Alternate angles are equal. Therefore, so they want to see a little knowledge that's showing how you just equate them two things and thing, right? So you want to write that. All right, what next? That's the easy part. That comes for 2 marks. Our next, a 1 mark scene happening here, which is our next easy part. They want you to find the bearing of P from Q. Bearing of P from Q, boys and girls. I'm telling you, extend them lines. Extend the lines. I'm doing this years now, and I'm saying that tips years now, and every time in the chat, the same thing is happening. People will be like, oh, and that's why you get the first marks in the bearings question. Extend them note lines. But good thing earlier I tried to snap the next piece of the question and bring it up, but it don't want to come up. Try again. Every now and then, Microsoft Whiteboard is play. Yeah, wrong way. Try it again. Copy. It copied. Okay, it's not copying. I'm trying here. Oh, look at it. No, like it was coming out behind the other image, maybe. Determine the bearing of P from Q. Oh yeah, look, it was coming out already. Ooh, look how much I that post. Determine the bearings of P from Q. First, I need to say, remember the from. Remember the from. If it's to, you watch this one. If it's from, you watch this one. Q is here. And the bearing of P from Q, this is what they're looking for. It needs to go all the way around from the north until it touch. Boom. So all our who's saying 47 wrong. Well, I have classes tomorrow. I have tomorrow. I have a Form 2-3 class and I have a Form 5 maths class. So I wouldn't be live tomorrow. I'll be live in class. Well done, Razak. Well done, Colonel. Bearing of P from Q. Now, why they were saying 47? They was watching this while they were saying 47. The bearing of P from Q. The bearing of P from Q is the 77 plus the 180. Sorry, the 133. Well, we get 77. We add the 56 plus the 180. What is that, yeah? 313. 313 degrees. Because you have to add this straight line, you have to add this 180. Keep in mind, a lot of straight line things will pop out on your hair. 180. You must know a little straight line is 180. Boom, bang. Whole thing is 360. If I need to subtract, I could subtract. And that kind of thing. And let's get the last part of this question. Calculate the distance RP. RP. Finally. Now you can't get a good bearings question. CXC missed. They miss if they didn't give you a bearings question. And you have to do some kind of sine rule, cosine rule, some kind of thing. They miss. And they don't miss. So the calculate the distance RP, this is what you're thinking. Are you thinking cosine rule or sine rule? Let me show you what I want, right? The distance RP. Well, if you're seeing something like this, a triangle, and you know this, and you know the angle, and they want you to find like this side, cosine rule. If they're seeing a triangle like this, and you know one angle, one side, and they're trying to find like a missing angle and they know the opposite side, then you're trying to do sine rule. Or if it was like you're trying to find this side, but you don't. So sine rule deals with the ratio of the angle to the opposite side. Cosine rule deals with like you have two sides that you know and an angle sandwich in between, and you're trying to find that thing opposite there. Right? Normally, cosine rule is the most used one, and it comes first, then the sine rule. And this one, I didn't even use the sine rule. After you do the cosine rule, you're done. So calculate the distance RP, cosine rule. There are like 3 ways this comes. They write the cosine rule. I tried to write. See if I could write it in the same way they have it in the formula booklet. So the formula booklet also has the common formulas that CXC will give you in the exam paper. So how I normally do is C squared is equal to A squared plus B squared minus 2AB cos C. But the book, the CXC has it. It don't matter, it's just which one you're calling A, B, and C. A squared is equal to B squared plus C squared minus 2BC cos capital A. Is it that what they normally do for them boys? Yeah, that's what they normally give you. So let me just show you who is who. This is the cosine rule. It's a little tiny there. And those of y'all who are interested in the formula book are saying this because I'm going to bust out just now. 472-4221. WhatsApp this number and get the book. If you want it now, like you could probably try going. You could call Mohammed's bookstore in Segonas and make sure they have it in stock. And you could go and get it there, the formula booklet for CSEC Maths tomorrow, if you need it now. But if you call this number, what will happen is they'll deliver it in TT Post. Not call, WhatsApp this number, they'll deliver it in TT Post towards your house, right? And it's only $100. Okay. So what is we doing with your life here? A squared is equal to B squared plus C squared minus 2BC cos A squared. A squared is PR. That is what we're trying to find. So this is like A. This is capital A over here. This is C. This is B. Y'all catch it? Or B, C. It don't really matter who wanna be B or C. So A squared is what we're trying to find. I could label it PR if that makes you comfortable. PR to B squared is equal to 210 squared plus 290 squared minus 2 by 210 by 290 cos of 56 is the angle sandwiched in between there. We got this whole thing on your calculator and then find the square root of it. Somebody help me out now. I'm not really feeling to go through all that. Oh no, I have a calculator right here for this. 210 squared plus 290 squared minus. Everybody, nobody student have Discord where you could go and get all the past papers in the wheel and thing, right? Follow the student have on Instagram. Follow the student have on Instagram now. And click the link in the bio and you can go and get all the past papers. Even past papers I currently talk about and thing. Sample papers. And that wants the students there who help you and thing. It's a little noisy, students. So PR is equal to the square root of 60090.3. I gain 245.1 kilometers. No, you can't go and wash no plate when I doing cosine rule. I mean, if I doing algebra, some basic algebra, you could go and wash your plate. But imagine you going out, you don't know this and you come back after you wash your plate to see this. Not a good look. Not a good look. Once he went and washed the plate and come back and he lost. Hard luck the colonel. Should have never washed that plate. Okay, so that's the cosine rule there. This is how bearings go down. And you can look up the topic bearings. So let me just do a little, for those of you who are about to do the exam on Tuesday, let me just do a little recap so you could center yourself in terms of what topics can come. Just give me a second. I'm just going to do a little recap so you could know how to revise, and I'll give you the best key for revision for those of you who busted along the last minutes here. You know how you're back. You know, I have your back. One second. I nearly done. I nearly get it. Right. Boom. All right. So CXC has 9 sections. The exam maths test are 9 sections. CSEC mathematics. You know why maths so hard? Is not only people hate maths and can't understand maths and thing. It's the longest syllabus. It's the longest. It's real plenty things you don't know. It's the longest syllabus for CXC by far. Longer than AdMaths by far. Although AdMaths is very hard for students to get, but it's longer. So one is number theory and computation. Why write through all of this and I can just snap it and bring it up, right? I just want to show you what you need to do now. These are the 9 sections that come in maths. Number theory and computation is like fractions, bases, how we count decimal places, significant figures, standard notation, approximation, all these kind of things, addition, multiplication, subtraction, division, just basic arithmetic, all of that. Consumer arithmetic, anything now dealing with dollars. So simple interest, compound interest, wages, the real topics in consumer arithmetic. You can look up Cohen's Spring on consumer arithmetic, see all the topics that could come. These two come in question 1. Then you have sets. This doesn't come in paper 2 anymore. It only comes in paper 1 and only like 3 to 5 questions. So it's not too bad. Sets not too bad. But you can still look up what I have on the sets. Measurement. This is a big topic, and I'll come back to this measurement again. So measurement deals with everything from volume to actual measurement, actual drawing, volume, area, surface area, all those things. And bring in measurement, maps, map reading, measurement, scales, statistics. Well, you know, statistics. Tough topics in statistics will be like certain types of probability, cumulative frequency, histogram. They bring in a lot of pie charts these days. They didn't bring pie charts in like 10 years, and then they bring 3 or something in the last 3 years. Algebra, everybody know algebra is relations, functions, and graphs. Now, algebra is the most extensive topic with 1,000,001 different parts, and it like solved it and everything. So you must know algebra. Relations, functions, and graphs. This section deals with starting from simple things like relation diagrams. So you have like this to this and 1 to 1, and only remember them thing, easy thing. So straight up the function, completing the square, and one of the toughest topics in CXC, linear programming. Graphs, coordinate geometry, so midpoint, length of a line. We did some coordinate geometry just now to equation of a line, parallel lines, perpendicular lines, how to draw on the graph, that kind of thing. Geometry and trigonometry, very big topic. Circle geometry, other types of geometry like understanding shapes, 3D figures, prisms, and things, what the rules surrounding them. Trigonometry, this is a wide topic. It could come basic or it could come advanced. We do some tricks just now. And of course, vectors and matrices, self-explanatory stuff. Now, most of vectors and matrices, I trashed out most of these topics in short bullet point videos on YouTube. So you could just search your topic and my name, and you could be good. Now, watch this. Going into the important thing here now. I was trying to teach you how to do the thing by. All right. So you have the paper 1. So it's 6 questions you get on sets. But notice where the real bulk of questions really come out. 8. Measurement, relations, functions, and graph, geometry, and trigonometry. This is the multiple choice questions, right? When you see MCQ, teachers write MCQ, they normally talk about multiple choice. Yeah, they remove sets from paper too long time. MCQ, multiple choice questions. They're throwing this recently, 4 vectors and matrices questions. It's not much on this. I have about call the question bank. It's in print right now. It's printing right now. Well, we get an estimate to finish up the printing. That book has all the questions, all the multiple choice style questions that CXC like to bring. So many people are like a bean order for that book. Anyhow, paper 2. This is 50% of your final mark. 50% of your final grade comes from paper 2, which is why paper 2 is the make it or break it paper. You're trying to study as much past papers, sample questions, multiple choice as you can, so that you can get between 50, and I posted this on my Instagram recently and on TikTok, between 50 to 60 out of these 60 marks. Ideally, it is possible to get all 60 questions in a multiple choice question. If you practice real plenty papers and things, you should be able to get over 55, even if you're not the best math student, just by pure memorizing what style of question comes. So you want to get this because this is this part is 30%. You don't want to play around with that 30%. You want to get between 25 to 30%. This part is struggle. Most people is fail this paper. Most people in the Caribbean is fail this paper. I might see maybe about 60 to 70% of the Caribbean failing this paper every single time. Sometimes only 30-something percent of people is pass maths in the Caribbean back in the days. Since my channel come out, raising number a little bit. Nobody number went up a little bit. I think it came just about 50%, 40-something percent of people passing maths. Maths, real people is fail maths is the worst pass rate. So you need to not play around with these people. So what people do is they fight up, they cry, they struggle, they realize they can't do this and they stop. Practicing multiple choice questions, you can bring it home with multiple choice if you try and get total any multiple choice questions. Go on the Student Hub Discord and get all the multiple choice questions you can get from maths and do them all. Between now and Tuesday, do like about 200. You can start to notice repeats. Paper one is food. Ask anybody who do paper ones before. Ask where it's gone. You study 2-3 paper ones, and all of a sudden everything started to become. Ask anybody who had the book that I had the question mark. I was selling it digitally. The whole of the Caribbean in 2020, like they had that book. 2020, they only do multiple choice questions, and I only had multiple choice questions in it back then. You're good to go. So I don't know how to say this again, but it's real beat out the paper ones. Now, big boy things now. The paper 2 is actually 10 questions, 10 compulsory. You have to do all the questions in the paper 1 now. 10 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These is, well, all of these actually, up to 7 is the section 1 questions. Normally the easier style questions, up to mid-level math students should be able to see their way here. Each one of these going for like 9 marks. You should be, this one I think is go for 10 marks. You should be able to get through most of this. These are the questions that most people is like, just don't get no marks in. This is the relations, functions, and graphs, geometry and trigonometry, circle geometry, trigonometry, the bearings and things, the tough questions. And this is the vectors and matrices, 10. Number 10. So I feel like what I have on YouTube and vectors and matrices, you should be able to make a note. You could make a note here. So really study, like if you want to know the first rough question to get you in vectors and matrices, and the hard thing is vectors and matrices. Study your vectors and matrices questions first. Then up next, you should study maybe completing the square and circle geometry. And you have to do all the circle geometry to get good in it. All the past paper circle geometry. All right, let's talk about question 1. Question 1 is number 3, consumer arithmetic, computation. Question 2 is just algebra, straight, just algebra, basic algebra, simultaneous equation, factorizing, simplification, linear, fractions. You can look up what I have on this. Question 3 is normally construction, where you need to draw a little triangle, or you might see some trigonometry or some basic geometry pop up there as well. Question 4, 5, and 6. Normally, these orders could get mixed up at 4, 5, and 6. It's normally either statistics, measurement, volume, surface area, something in measurement with the map, something like that, some statistics with histogram. This is where the statistics question come. No statistics come in here. This is the, oh God, statistics will come in 4, 5, or 6. I think 6 is where it's normally come. Or you could get you could get basic trigs, that kind of thing. So that's 9 marks, 9 marks, 9 marks. All of these you want to secure. You want to secure their marks. Practice it, practice it. I hope all you're writing and taking note. You could always come back to the video and replay this part. Number 7 is the same question every year, all the time. It's an investigation question. Look up this. Anybody could learn this and get the 10 marks. How I teach this? I have a nice video on YouTube. Search Kerwin Springer investigation. And next thing they call this is series and sequences. And I break up the different ways from easy to hard that this could come. That is the question where they bring a pattern, and then the pattern is get bigger, and then they'll bring a table and they'll ask you to finish out the table. I'll show you all the different ways with examples how to do that on YouTube. As I said, if you feel like you want a whole class and a lesson on this, just join my lessons class. So investigation, series, and sequences, great. So you should be able to see a way and try and get down some marks. And if you could get nearly all the marks in this, you pass this, you pass that, you pass maths. That's the way to pass maths. Now, if, and in addition to this, if you do a SBA and your SBA grade is coming to this, and you get 20% in your SBA, you're inside the game. One of the toughest thing, like if you are weak, as I said, if you're a weak math student and you're trying to figure out how to pass this subject, memorize off your multiple choice. Don't play the fool with your teacher and deadlines and deliver your SBA late. Deliver your SBA early. Get your full marks in your SBA. Go through it, everything with your teacher step by step. Ask them how you could fix it up, how you can do better, what they need, what they're testing on. Watch all my videos on SBAs. I have sample SBAs. I even have a book called the SBA Bank with 20 sample SBAs. Same number again. You can WhatsApp or you can check me on Instagram, message me on Instagram. You can get your hands on that book. It's available in bookstores and Shogunas as well. We could just message me on Instagram for anything that you need to clarify. I'll message back in the morning. And you're inside the game for SBA. Try and get the full marks here. 20% and 30% is how much? 50%. You pass. Grade 3 in maths is normally somewhere around, when I work it out with people, is normally somewhere between 50 to 60%, and you get a grade 3. So you just need to get a little bit of dust in the paper too on your inside. It's possible for those of you. I have taught thousands of people online and in person and indirectly on the channel. And some of them are really terrible at maths. 4 times, 5 times they're trying to do maths. And by the hook and the crook, they make it through. And sometimes you don't love maths. You don't want to ever see maths again. You just want to pass it, get a grade, and be able to get a job. So I must be preaching to somebody here right now. This is the way. Don't get frustrated. Plan for them. And you can make it. You can make it through the door. All right. So you know what you need to do. You know what topics you need to look at. Go and put on the work. Remember, when you're revising maths, you're not doing this. Read, watch video, read. You wouldn't learn anything. You need to actually take your pen, take your calculator, take your book, and write out 1,000,001 questions and do it for yourself. Do all the questions. Do the weak areas, not the strong areas. And they're doing past paper questions. They're not doing questions from your book necessarily. You want to do stuff that you know that CXC is testing. You cannot read it. You can't read the maths earlier. Parents, if all you're watching and the students say they're studying and all you see them is having the book on the table and they're just there and the phone there and the book there and nothing in writing, it's very easy to know if you're studying maths. And just show. That was I ask people when I used to go and do one-on-one teaching. Just show me the book you was working in. And if you have no book, you ain't learn nothing. You ain't learn nothing. So you need to have a book with all your questions where you're doing your questions and things. Otherwise, you ain't learn nothing. Because CXC not going to ask you to talk to them. They're going to ask you to write on a paper for the exam. So I don't want to buffing you too much there, but you need to write. You need to write for maths. You need to do the questions. It's one thing for you all to come and sit down and watch me in this video, sit down and watch all the videos on the channel, and you see me do it and you're like, I get it now. I understand it. If you don't take the question apart and write it down and do it back for yourself, you're not going to see the errors that you could come across in the exam. And you can be in the exam room like, I knew this, I see when you do this, but what's the next step again? You freeze up. All right, so let me know, kill a little too much talking. Love and blessings. There's a lot of stuff on the channel, right? So you don't necessarily need me to come live, but if I come live tomorrow, I will try. But you could always just search the topics. I have the full list here. You could always just search the topics on the channel and do the thing. Well, press like on the video. You can close the chat and press like on the video. So would the recording for the session be available for viewing later? Of course. Can someone tell me what percentage is considered a grade 2? Now, normally when I work out percentages with students, and they get normally between like 62 to like 72 or 73%, they normally get a grade 2. When they get above like 75%, that grade 1 secure. When they work out the whole average percentage. Always writing, or write the maths. Blessings to all. Blessings and exams on Tuesday for those of you all who are doing it. Those of you all who have class with me tomorrow, see you tomorrow, bright and early. Well, in the afternoon. Till we meet again. Till we meet again. And in the broadcast now. Or you can feel free to share it with people and tell them, go and check out this.